Good morning, student. Welcome to the second lecture of Physics Bridge course, class 8. In last class, we studied about speed, average speed, and their SI units, and then we solved some problems based on the relation between speed and average speed. And then we learned about uniform and non-uniform motion. Then we discussed the distance time graph, and then we differentiated uniform and non-uniform speed according to the graph. Now in today's lecture we will learn about a simple pendulum. This topic will help you understand some important concept that you will study in physics in this grade. So let's begin. Simple pendulum. What is simple pendulum? A pendulum consists of a small metallic ball called a bob, which is suspended by a long and non-extensible thread from a rigid support so it can swing freely about its point of suspension. What is simple pendulum? સિમ્પલ પેન્ડ્યુલમ એક આખી સિસ્ટમ છે જેમાં એક સ્મોલ મેટાલિક બોલ હોય છે. I will show you. One second. So this is a metallic ball which is named as bob. It is called bob, bob, which is suspended by a long non-extensible thread from a rigid support. This is the thread here, which is long. You know what is long. And non-existent extensible. What is non-extensible? Which cannot be stretched. એ લાંબી પહોળી ન થાય, ખેંચાય નહીં, એકદમ સ્ટ્રેટ કડક થ્રેડ છે જે ખેંચાય નહીં. રબર હોય તો રબરને આમ પોળું કરીએ તો પોળું થાય, તો એક્સટેન્સિબલ કહેવાય. નોન એક્સટેન્સિબલ મીન્સ a straight thread which can't be stretched. So non-stretch also we can say, non-stretch thread from a rigid support. કોઈ એક fixed support. Rigid support means કોઈ એક fixed support with the movement of pendulum that should not move. So a fixed support so that it can swing freely from about its point of suspension. Point of what is point of suspension? Point of suspension જે point rigid support અને thread ને connect કરીને bob ને swing કરવા માટે, freely swing કરવા માટે allow કરે, એને point of suspension કહેવાશે, right? So what is simple pendulum? It is a metallic ball called bob which is suspended with a long and non-existable or non-stretched thread from a rigid support so that it can swing freely above its point of suspension, right? Now let's take an activity to make simple pendulum. uh, we will do an activity how to make a simple pendulum at home. So materials required are thread, then hexagonal nut, adhesive tape, pencil, ruler and pair of scissors. So let's get started. Now first step in your, stick a pencil on the table using adhesive tape such as 2 centimeter of pencil hangs over the edge of a table. Like what you have to do, take a table. If this is a table, edge of a table, now we put here a pencil. So from the edge of the pencil, from the edge of the table, pencil is kept 2 centimeter. Pencil is kept little bit outside of the table. So this distance would be 2 centimeter. That would hang it. And then put other parts on the table and then stick it with a tape so it will not move. This will form a rigid support of to make a simple pendulum, right? Now cut a 60 centimeter long thread. Cut a thread with the help of a scissor. Tie a net to one end of the thread. Now you cut a thread. Now try to tie that nut. You have nut, right? Nut is that bolt, screw bolt. You know that bolt. Yes, that is what nut is. Nut bolt. Yes, something like this. This is screw, like bolt. Sorry. And this will be pointed, so it can easily dig. And to tighten this, there will be a knot like this, so it can tighten the bolt. So tie that thread on that nut. So now one end is tied at the nut, then you can tie another end at the pencils part, which is 2 centimeter outside the table, which is hanging outside the table. Now observe the simple pendulum that you have made. Identify the different part of simple pendulum: rigid support, point of extension, non-extensible thread, and bob. Now you made your pendulum is ready. Now what is asked here is you identify the parts that is there in simple pendulum. So this is an rigid support, this table, right? So the first part is rigid support, we complete. This is rigid support, right? Point of suspension means the point which is connected to move freely, to move the simple pendulum freely with the uh, rigid support and a thread. That point is point of suspension. So this is the point of suspension, right? Non-extensible thread, this means that thread. And a bob, here bob is the nut, right? See here, point of extension, non-extensible thread, bob or nut, or rigid support, right? These are the parts of simple pendulum. Measure the length of simple pendulum. Step 1, take a meter scale and measure the vertical length from the point of suspension to the approximately center of the bob. This is the length of pendulum. So how do we measure the length of pendulum? For length of pendulum, if this is the bob, so make a center here, approx center, this is the center. If suppose from here to the rigid support, that length is length of the pendulum. Okay, next. So measuring the length of simple pendulum, find the three readings to find the mean length of the pendulum. So what is mean length? Mean length is average mean length, that is all the readings divided by total number of reading. If we add all the reading in the then divided by total number of reading, we can get the mean length of simple pendulum. So mean length is equal to reading 1 plus reading 2 plus reading 3. Here there are 3 readings, so total divide by number 3. Okay, if here given is 4 reading, reading 1 plus reading 2 plus reading 3 plus reading 4, then we divide it by 4, right? Now, motion of simple pendulum. Observe, does the motion of the bob of a pendulum repeat after a certain time interval? When you start a simple pendulum for motion, then you see that after some times the same motion is repeating. Right? First, when you, so first position, the bob was at rest, it will be here. Then you pull bit on some side. If you pull this side, the bob will be here, and then you will release. So it will go to this side and again back to this position, then back to this position, and less, and he will be, it will stop at the center point, right? Where this is perpendicular to the rigid support, right? You can say that way. Yes. Yes, bob come back to the position from where it was released after a certain time interval. Therefore, its motion is periodic. So this motion is periodic motion. When we release an object from one point and then it moves and then again it comes back to that certain that position and in perfect time interval, and this motion is called periodic motion. Now the motion of simple pendulum, the mean position m, we denote it as m, the position of bob when the pendulum is rest. The mean position, what is mean position? Mean position કોને કહેવાય? એમ થી રિપ્રેઝેન્ટ થાય છે, કેપિટલ એમ થી. અને જે રેસ્ટમાં પેન્ડ્યુલમ જ્યારે રેસ્ટ પર હોય છે, which is perpendicular to rigid support, this point is at rest when pendulum is at rest. So this position is known as mean position, capital M. Now the extreme position are the position E1 and E2 are the position of the bob where the distance of bob from its mean position is the max. Now the second point is extreme position. Extreme position kone kehvaય? First it is denoted as E1 and E2. Then what is this? જ્યારે આ bob છે, as rest પર છે, you take it to the certain point for a moment, then you release it from here. So the maximum height, maximum distance covered by the bob in left side and in right side from the rest point, that is the extreme position. If we start અહીંયાથી જ્યારે તમે સ્ટાર્ટ કરો છો, અહીંયાથી પુલ કર્યું, પુલથી એ અહીંયા આમ જશે, આ એની મેક્સિમમ ડિસ્ટન્સ કવર થયું, પછી પાછું અહીંયા આવશે ત્યારે એક મેક્સિમમ ડિસ્ટન્સ કવર થયું, but after that slowly the distance will be less and it will be again at the rest, right? So the maximum position that is obtained by the bob is extreme points E1 and E2, and the mean position when the bob is at rest or pendulum is at rest, the mean position is the M. What can you say about the speed of the bob when it reaches either of the extreme position? The speed of the bob is observed to be 0 for just a moment when it reaches either of the extreme point. હવે જ્યારે અહીંયાથી આ બોબ છે, if you pull it out here and then you release, અહીંયાથી રિલીઝ કરો એટલે આ સાઈડ આવશે, અહીંયા એનો એક મેક્સિમમ પોઈન્ટ હશે, એ મેક્સિમમ પોઈન્ટથી જ્યારે અહીંયા આવશે પાછું આ સાઈડ, at that just for a moment, just for a second, આની સ્પીડ એકદમ સ્ટોપ થઈ જશે. It will be stopped there. એક આવી રીતે પેન્ડ્યુલમ મૂવ કરતું હશે તો પેન્ડ્યુલમમાં if you start from here તો આ પોઈન્ટથી જ્યારે તરત આ પોઈન્ટ પર આવશે, but for a microsecond at that point the speed of this extreme position will be 0, and at this side also જ્યારે અહીંયા બી આવશે ત્યારે બી એક એવું માઇક્રોસેકન્ડ હશે જ્યારે એની સ્પીડ 0 થઈ જશે. એટલે the speed of the bob is observed to be 0 for just a moment when it reaches either of the extreme position. Try making an pendulum. Take a ball. I will give you a simple thing. Take a ball. If you want to observe this, take a ball, tie it with a thread, put your hand in the air and just try to move left to right, pendulum like a pendulum. You can observe when you can see that ball is going on the left hand side, the top position, extreme position. At that point, just for a microsecond, the ball is stopped at that point. So when the body is at rest, the motion is 0, the speed is 0, right? Next, slightly place the bob of the pendulum to one side and then release. Identify the option in which the motion of the object resembles the motion of the bob. So what is asked કે તમે એક જે પેન્ડ્યુલમ બનાવ્યું એને એક સાઈડ પર આવી રીતે સાઈડમાં લઈને એને રિલીઝ કરો એટલે એ શું કરશે, E1 ટુ E2 E2 E1 E1 E2 એવી રીતે એ પેન્ડ્યુલમ મૂવ થશે. તો એ જે પોઝિશન પિરિયોડિક પોઝિશન મૂવમેન્ટ છે એને આ ત્રણ એક્ઝામ્પલમાંથી કોની સાથે કમ્પેર થાય? તો વી કેન સી ઇન ધ સ્વિંગ. હિયર in a swing also we can see this is, if this is a pendulum, this swing is at rest, it will be like this, then it will work as like this, e1 e2 e1 e2, and then again after some time if we did not give external pressure force, it will be stopped at one position, right? So the answer is A, right? Now, a periodic motion in which the objects move to and fro about its main position is an oscillatory motion. Now, a simple pendulum performs oscillatory motion. So, what motion does a simple pendulum perform? So, a motion in which the objects move to and fro about its mean position. So, what we know, this is the mean position, M, capital M, we already know, we see. Then, from the mean position, it moves from to and fro, to and fro, this side. So, to and fro, moves to and fro from the mean position is oscillatory motion. So, this is known as an oscillatory motion, and simple pendulum performs oscillatory motion, right? We seen two motions, periodic motion and oscillation motion. So what is the difference between, because I said that pendulum is both having periodic motion and oscillation motion. So what is periodic motion, what is an oscillation motion? So periodic motion is defined as the motion that repeats itself after a fixed interval of time. That we can say periodic motion here, periodic motion. If this is a pendulum here, or a bob or a nut, periodic motion is defined as a motion that repeats itself after a period of time. After some period, you can see that this motion is repeated. See, if it's from a mean position, it is extended to its E1 part. Then again, it is back to its mean position. Then again, it is extended to the E2 part. So this process is going on continuously until it is stopped again at its mean position. So in a fixed interval of time, this position from its mean position to E1, then mean position E2 and mean position. So this motion continuously goes on. So this is periodic motion, right? Now what is oscillatory motion? Oscillatory motion is just one movement from mean position to extreme position to mean position and extreme position and then to a mean position. So this one rotation, single rotation, is oscillatory motion. So we can say also that oscillatory motion is also a type of periodic motion. Periodic motion continues, goes on continuing, but oscillatory motion is just one part. That oscillatory motion is defined as a the to and fro motion of an body of at its fixed position or fixed time. Yes. Okay. Now let's see some terms associated with simple pendulum. Oscillation. An oscillation of a simple pendulum consists one cycle of to and fro motion of the bob, where it swings from its mean position M to the extreme position E1, then to the extreme position E2, and then back to the mean position. જે હમણાં જ મેં લાસ્ટ કીધું જ્યારે ડિફરન્સ કહેતી હતી પીરિયોડિક મોશન ને ઓસિલેશન મોશનમાં, કે oscillation motion is just one cycle of doing both the extreme point and back to the mean position. Here what is explained કે simple pendulum માં oscillation motion એક cycle consist કરે છે જેમાં એ mean position એની first mean position થી E1 position પર જાય છે, ત્યાંથી પાછું E2 position પર આવે છે અને પાછું again mean position પર આવે છે. This is what is oscillation motion. What is amplitude? The maximum distance of a bob from its mean position on either side is the amplitude of pendulum. Here we said that the maximum distance. So if we see that from this point we say can this distance covered this much distance, the bob has this maximum distance. After that here also bob has this maximum distance, but after that it is going slowly, the distance is getting less. So this distance is known as amplitude of pendulum, and the amplitude depends on the angle through which the bob is moved initially from its mean position. So this angle from its mean position to its extreme position, this angle is amplitude that depends on the angle through which the bob is moved initially from its mean position. Time period. The time taken by the pendulum to complete one to and fro motion or one oscillation is known as time period. So what is time period? One oscillation that is traveled in that time is time period. One oscillation means mean position to extreme position, then to again extreme position another side, and to again to a mean position. That completes one oscillation. So that much time taken by to complete one oscillation is time period. So we can say that another way to find the time period is to start observing the bob when it starts from E1 and follows this path: E1, M, E2, M, E1. If we start from the center, then we can say M, E2, M, E1, and then again M. But if we pull this side, if we pull the nut or bob on left hand side or right hand side and we release from there, so we can say E1, M, E2, M, and E1. So this is now this E1 becomes the initial point, but so it's either ways, whichever you like. If we take from the M mean position, so mean position E1, E2, and M. If we take from the E1 as a mean position, E1, M, E2, M, and E1, that will complete one oscillation, right? Can you accurately measure the time taken to complete one oscillation of a pendulum using a stopwatch? It is not easy to measure the time period of one oscillation. Thus, we measure that of 15 to 20 oscillation. Now, the time period of the pendulum can be calculated by using the following formula. So, first the question is, okay, time taken to complete one oscillation. You can easily do it with the stopwatch. એટલે તમે stopwatch ચાલુ કરીને તમે જો કે એક oscillation થઈ ગયું. No, we can't do that accuracy, right? કે ભાઈ અત્યારે ચાલુ થયું છે, it will just go very fast. So it will not be easy to calculate that. So what is the solution? If we do 20 to 20 oscillation, 15 to 20 oscillation, then we can find the number of time in one oscillation. So now for that we need time period formula, and that is total time taken to complete n number of oscillation divided by total number of oscillation. So total time is if to complete 20 oscillation it took 30 seconds, and we can know that it completed 20 oscillations, so we can write 30 divided by 20. So 3 by 2 is the time that is taken to complete one oscillation, right? So that like that we can calculate the total time period means the oscillation motion for a of a periodic motion, right? A single movement of to fro is an oscillation motion, and that oscillation motion is traveled in a time period or calculated as a time period. So we can know the oscillation time period of oscillation motion. If the time taken by the simple pendulum to complete 20 oscillation is 60 seconds, then what is then calculate its time period. So here there is a question કે સિમ્પલ પેન્ડ્યુલમ છે એ 20 ઓસિલેશન્સ કરે છે in 60 seconds. So time period ની formula શું છે અને total time taken and total number of oscillations. So total time is here 60 seconds and total number of oscillation is 20. So 0 0 cut, 2 threes are right. So 3 seconds is taken for each oscillation to complete its oscillation. For pendulum to complete its one oscillation. Okay, 3 seconds is taken. Right. The time period of the pendulum can be calculated by using this formula. And so in this case, time period is equal to 60 seconds upon 20, which is 3 seconds. Now let's take a quick summary. An oscillation of a simple pendulum consists of one cycle of to and fro motion of the bob. The maximum distance of an bob from its mean position or either position is amplitude of the pendulum. The time taken by the pendulum to complete one to and fro motion or one oscillation is time period, and time period of the pendulum when it's complete an oscillation can be calculated by using the formula time period total time taken to complete an oscillation divided by total number of oscillations. Now let's do an activity to determine the time period of simple pendulum. So first make all this thing ready and make a simple pendulum as we already learned how to make a simple pendulum. Get ready a simple pendulum. Now what you will do, take your bob or nut slightly to one side and make sure that string is straight and release the bob gently without pushing. Just release it. Leave it. Then start the stopwatch when the bob reaches the extreme position on the other side. જ્યારે અહીંયા if we release from here this point, and when it reaches here, start the stopwatch. So here this is the mean point and you will count 20 oscillations. Start counting the oscillation and you will count from this point one oscillation, two oscillation, three oscillation, four oscillation, like this you will count till 20th oscillation and note the time. Stop stop the stopwatch after that and just make an table that number of oscillation. Make this do this activity for 2 3 times and fill this table time taken and time period. Note that 20 oscillations are there in the cell. So doing this one time. Now calculate the time period for one oscillation of pendulum using the formula. So you have to calculate that first time period, that when three oscillation took how many seconds, and for that one oscillation what time will be there. Write this in your notebook and then calculate the mean time period using the formula given below. So time period is also there. Time taken is, what is time period for one oscillation, and time taken is for 20 oscillations, right? So take a table, do this 2 3 times and then calculate mean time. Mean time is like an average time. So add the time period, mean time period. So add the time period 1 and 2 and then divide it by 2. So by this we can get an average mean time period. Okay. Write these two questions in your notebook and send it to me. Now let's do some questions based on what we learned today. First question, Kavita attached a stone to one end of the wooden rod. She then suspended it from a hook about which it could move freely. So first question, can this setup be considered as an example of single pendulum? Justify your answer. And second, if the wooden rod is replaced by a long rubber band, will the setup be considered as an example of simple pendulum? Justify your answer. So what is said that Kavita attached a stone to one end of the wooden rod. So this is wooden rod, if we consider, and then Kavita attached a stone here, right? and then he she hang it on a hook, so it can move freely. So the question is, first question is, can it consider be as an example of simple pendulum? Can this be considered as a simple pendulum? Yes, we can consider as a simple pendulum, because stone will work as an bob. This thread will work, this wooden rod will consider as a non-extensible thread that will not extend itself or it will not stretch, and then it is hanged on a hook, so hook will allow this pendulum to move freely from its extreme position to mean position. So we can use this an example of a simple pendulum, right? If the wooden Now second question, if the wooden rod is placed by a long rubber band, now this wooden rod is placed with long rubber band, then it is considered as in simple pendulum? Obviously not. When I was explaining this topic, I said that if we consider a thread as a rubber band, then it will just stretch. We need as non extensible thread, which is non stretch thread. So if we replace with the rubber band, it will not consider as an example of simple pendulum. Right. Now you write all this question and answer in your notebook. Last two questions, and here there are three questions. So total five questions in your notebook, and send it to me as an homework. So here, yes, this setup can be considered as an example of simple pendulum, because the motion of stone will be periodic, since the wooden rod acts as a non-extensible thing. And no, for the second answer, when we replace by the long rubber band, no, this setup cannot be considered as an example of simple pendulum, because the rubber band is extensible and its motion will not be periodic. Second question. A simple pendulum takes 40 seconds to complete 20 oscillation. Calculate the number of oscillation it will perform in 30 seconds. So what we will do here, we will find that one oscillation takes how many time, and then we will divide it with 30, so we can get total number of oscillation in 30 seconds. So simple pendulum, for one oscillation it will take, we have the formula, time period is equal to total time taken divided by number of oscillation. So 40 divided by 20, 0 0 cut, 4 2s are. So 2 seconds will be taken to complete one oscillation, right? So we have to write here 2 oscillation to complete one pendulum or one oscillation. So calculate the number of oscillation to perform, it will perform in 30 seconds. Now we have to calculate the number of oscillation that it will perform in 30 seconds. So total num is 30 seconds, and for one oscillation it will take 2 seconds. So 30 divided by 2, which will we get is 15. 2 15 is that. So 15 oscillation is done in 30 seconds, right? So given time, the time taken by the pendulum is complete 20 second, 20 oscillation, which is 40 second, and asked is oscillation performed in 30 seconds. So first time period is total time, total number of oscillation, time taken by total number of oscillation upon number of oscillation. So by solving that, we can say that total 20 oscillations to, and to complete that it is 40 seconds. So 40 divided by total number of oscillation, which is 2 second. And now what is asked, that time taken to complete one oscillation is 2 second, we found. Therefore the number of oscillation completed in 30 seconds, we have to find the oscillation that is performed in 30 seconds. So 30 divided by per oscillation, so it will give us 15 oscillations. So the pendulum will perform 15 oscillation in 30 seconds. This is the answer. Now third question. Figure 7 shows an oscillating pendulum. The time taken by the bob to move from A to C is T1, and from C to B is T2. The time period of this pendulum is. And here are the options: T1 plus T2, 2T1 into T2, 3T1 plus T2, and 4T1 plus T2. Which is the correct option? We have to say that. Now let's see. Let capital T be the time period of a given pendulum. So capital T is the time period, which means that from A position to B position and B position to A position, that is the time period. What is time period? Time period is and time for one oscillation. So one oscillation is from A point to B point and B point to A point. So capital T is the time taken by pendulum to complete one oscillation, right? No, as shown in adjacent figure, T1 is taken time as given in question, that A to C when it's travel, when the bob travels from A position to C position, it takes T1 time, and from again C position to B position, it takes T2 time. Now, what is the for time period for A to B taken time is, so we can write T1 plus T2 for A to B, right? But we know that capital T is the time for one oscillation. Now we can see that this is only half oscillation because it is not coming back. We have to calculate it by A to B. We have not calculate by A to B to A again, right? એટલે અત્યારે આપણે જે કરીએ છીએ ફર્સ્ટ A પોઝિશનથી B પોઝિશન સુધી જઈએ છે અને B પોઝિશનથી A પોઝિશન પર આવીએ ત્યારે એને ટાઈમ T કેપિટલ કહેવાય. બટ આપણને શું ફાઇન્ડ કરવાનું કીધું? ખાલી A to B પોઝિશન, જસ્ટ એ સિંગલ સ્ટેપ. સો એનો મતલબ એમ કે જે ટોટલ ટાઈમ T છે, ટાઈમ પીરિયડ છે, વન ઓસિલેશન છે, એનું હાફ ડિસ્ટન્સ કવર કરે છે. So we can write that T1 plus T2, એટલે આ બેનો ટાઈમ ટોટલ કરીએ ત્યારે આપણને જે કેપિટલ T ટોટલ ટાઈમ જે છે વન ઓસિલેશનનો એનું હાફ કરવું પડે, રાઈટ? સો ફોર ધેટ નાવ we can see T1 plus T2, T1 plus T2 is equal to T by 2. Now we take 2 on left hand side, then we can multiply it. From divide it will go to multiplication, 2 times T1 plus T2, which will give capital T. If we see direct logically કે એક આવી રીતે પેન્ડ્યુલમ ટ્રાવેલ કરે છે from position R to position R. હવે વન ટાઈમ પીરિયડ માટે એ પાછું બી આવે છે ત્યારે એક ટોટલ ટાઈમ પીરિયડ કહેવાય. તો હવે આપણને ક્વેશ્ચન પૂછ્યો છે A to B જ માટે, તો એ ઓલરેડી જે ટોટલ ટાઈમ છે એનું હાફ થયું, રાઈટ? સો ઇઝીલી ઇટ ઇઝ પ્રૂવન. ઓર વી કેન સે કે જ્યારે આ બે વાર ફર્સ્ટ હાફ પાર્ટ 2 ટાઈમ્સ રિપીટ થશે ત્યારે એક ઓસિલેશન કહેવાય, એ બી કહી શકીએ. એટલે ટોટલ ટાઈમ જે T છે એને હું આ જે ડિસ્ટન્સ છે એનું 2 ટાઈમ્સ કરું ત્યારે એ ટોટલ ટાઈમ વન ઓસિલેશનનો મળશે. યસ, ક્લિયર? So write this all questions, this 3 and before that 2 questions in your notebook, and we are here completing the physics bridge course. In next lecture we are going to start new chemistry bridge course. Thank you all.